if I told you things I did before, told you how I used to be, would you go along with someone?
Section 2.3 is on squares and square roots, and a lot of this should be review for you because you've done this in previous years, especially grade 8. Squaring a number. What's it mean to square a number? Well, another way of thinking of squaring a number is to raise a number to the second power. And what that means is to multiply a number by itself 2 times. You know that, right? For example, if I was interested in what 11 squared is, so I'm squaring the number 11, that's the same as raising it to the second power, right? That number up there, that little 2, that is the power or the exponent. Actually, let's get really clear about this. If I have something like 3 to the 5th power like that, this number on the bottom is called the base. This number up top is called the exponent. And the whole thing, the 3 to the 5th, that's called the power. So this is kind of a misnomer. It's kind of a bad name for this when we say raise it to the second power, because instead of saying this is raised to the second power, don't you think we should say it's raised to the second exponent? Anyway, 11 squared is the same as, is the same as 11 times 11. We've multiplied the number by itself 2 times, and what that equals is 121. I think you know that. Alright, square root is just the opposite of squaring. You could kind of call it unsquaring, although that's not a real term, but sometimes I use that term. And the question you want to ask yourself with square roots is, what number do I multiply by itself to get the original answer? For example, if I was interested in the square root of 36, then we know the answer to this is 6, right? Why? Well, it's because the number I multiply by itself to get 36, the original number, is 6. I go 6 times 6 to get 36. Perfect square. A perfect square is any number whose square root is a rational number. So, for example, 0. The square root of 0 is 0, so that's a perfect square. 1. The square root of 1 is 1, so that's a perfect square. How about 2? What's the square root of 2? I don't know. The square root of 2 is 1.41 something. It's not a rational number, so that's not a perfect square. So far we have 0, 1. What's the next one? 4. What's the next one? 9. How can I get these really fast? Well, this is 0 times 0, this is 1 times 1, this is 2 times 2, this is 3 times 3, so the next one should be 4 times 4, 16. Next one's 5 times 5, 25, 36, 49. Where am I at? That's 7 times 7. 8 times 8, 64. 9 times 9, 81. I know I'm writing a lot of them here. You're probably wondering why I'm writing all these. It's actually kind of important that you learn or memorize or remember how to generate this list of numbers. So what am I up to? 13 times 13, 14 times 14 is 196. And I usually tell people if they're familiar with 15 up to 15 times 15, you're pretty good. Okay, we'll talk lots about these numbers over the next few days. So I'll write them once here. I'll probably end up writing them a few other times. So if you were to take the square root of any of these numbers, you'd get a whole number. But you also have, there's fractions which are also perfect squares. Like what if we wanted to know the square root of 9 over 25? Do you remember this from grade 9? If you have a fraction, you want to get the square root of it, take the square root of the top number. Well, the square root of 9 is 3. And get the square root of the bottom number. Square root of 25 is 5. Finished. You can even take the square root of a decimal. Some decimals are perfect squares. Like this is a perfect square here. Remember this from grade 9? It's not so important this year, but let's take a look at it. What's the square root of 36? Because 36 is a perfect square. The square root of 36 is 6. But obviously 0.36 does not equal 6. Remember what you do? Since it says 2 decimal places, the 3 and the 6 are in 2 decimal places there. You want half as many here. So it should be just 1 decimal place. It should be 0.6 or 0.6. If you don't remember that from last year, it's not a huge deal. But that is something that you learned last year. Okay, we're going to find square roots without a calculator. How are we going to do this? Good news, we're going to do something we did last class. We're going to do the prime factorization. That's the tree factors, right? Factor trees. So think of any two numbers that multiply to get 256. I don't know. It's an even one, so let's say 2 times what? 2 times 128. What goes into 128? How about 2 times 64? So these are both prime so far. So those are done. Let's keep going with the 64. Well, 64 is 8 times 8, and 8 is 2 times 4, and 4 is 2 times 2. 8 is 2 times 4, and 4 is 2 times 2. Wow, look at all these 2's we got. 2, 2, 2, 2, 2, all that. So what we found is we were looking for the square root of 256, and we found that the square root of 256 is really the same as 256 prime factorization is 2 times 2 times 2 times 2 times 2 times, how many? 2, 4, 6, 7. Oh, I missed one. Did you spot that? I missed this guy here. So 8. 1, 2, 3, 4, 5, 6, 7, 8. Now there's an important fact you need to know here. I'll write it in this red square, rectangle, whatever here. If you're looking for the square root of a number that's squared, that's the same as the square root of the number times itself, because that's what x squared means, right? X times x. And what that is equal to is x. This is really important. So if you wanted to know what the square root of 9 squared is, it's 9. If you want to know what the square root of 33 squared is, it's 33. If you want to know what the square root of m squared is, it's m. Why is that helpful? Because we kind of have that a whole bunch of times here. Every time we get a pair of these, a pair, a pair, a pair, a pair, you're going to be able to use this fact. So the square root of 2 times 2 is 2, and the square root of 2 times 2 is another 2, and the square root of 2 times 2 is another 2, and the square root of 2 times 2 is another 2. So what you end up with is the answer is going to be 2 from this pair times 2 from this pair times 2 from this pair times 2 from this pair. What's that equal? 2 times 2 is 4, times 2 is 8, times 2 is 16. The answer is 16. Okay, I'm just going to show you another way, which is a silly way, but some students seem to like. So you want to think of this sign here is called a radical, by the way. That's a radical. And the number out front, which you don't see right now, there's a little number that goes right there. In this case, it's invisible. Do you know what number is actually floating there that you can't see? It's a 2. If there's no number, the number is a 2 in this case. This number is called the index. The number inside is called the radicand, but let's not worry about that right now. Okay, so here's a silly way you can think of it. Think of the radical here. It's been this radical nightclub. It's just radical. And this 2 out there tells you how many people there needs to be to get into the club, or how many people there needs to be to get out of the club. So this is a special club here, and you can only go in or out if you do it in pairs. So these things, these 2's are all in the club. They want to come out. They can only come out in pairs. So this 2 comes out together, and then you only have one of them. This pair comes out together, and there's only one of them. This pair comes out together, and that's... Anyway, I don't know. Sometimes students like that. Kind of cheesy, but I made it up, so let's pretend we like it. Alright, square root of 900. So same thing, start with 900. We're going to break it down. Well, I know that 90 and 10 make 900, and I know that 9 and 10 makes 90, and 3 and 3 make 9, and 2 and 5 make 10, and here's another 2 and 5 here. So these are all the prime factors there. So that means that the square root of 900 is equal to, it's the same as 2 times 2, 2 times 2, times 3 times 3, times 5 times 5. And this is club 2, right? The index is 2. So we're looking for pairs. This is a pair that can come out. You couldn't pair up a 2 and a 3, right? When I say pair, they have to be exactly the same. There's 2 3's, they can pair up. There's 2 5's, they can pair up. So what comes out of the club? The 2 2's come out, and we're just left with one of them. The 2 3's come out of the club, just one of them. The 2 5's come out, just one of them. So the square root of 900 is equal to 2 times 3 times 5, which is 2 times 3 is 6, times 5 is 30. What's the square root of this giant number here? So we want the square root of 25 and then 6 zeros. 1, 2, 3, 4, 5, 6. So rather than doing a factor tree, do you remember if you have tons of zeros here and you have a perfect square out front? There's a very fast way of doing this. Again, you'll learn this in grade 9. What's the square root of 25? The square root of 25 is 5. Now we have 6 zeros here, right? There's 6 zeros. In order to multiply two things together and get an answer with 6 zeros, you know how many zeros there must be in this number here? There must be half as many, so there must be 3 zeros. So the answer is 5,000. So if you're not quite clear about this, the 5 came from the square root of 25, right here, right? Square root of 25. And the 3 zeros here came from half of the 6 zeros. You actually could have done that back up here. Square root of 900. Oh, 9's a perfect square. Square root of 9 is 3. And there's 2 zeros. We want half as many. There'd just be 1. 30. That's exactly what we got. What if it was the square root of 9,000? Square root of 9 is 3. We have 3 zeros. Do we put 1.5 zeros? Something like, I don't know, like that or something? No, this is not a perfect square. Okay, the square root of that is not a rational number. It has to be an even number of zeros. Alright, now we're going to do almost the same thing over again, except this time it's cubing instead of squaring, but it's really just everything's the same, except this time you're raising the number to the third power. It means to multiply a number by itself 3 times. So, for example, if we wanted to do 5 cubed, that does not mean 5 times 3. That means 5 times 5 times 5. 5 times 5 is 25, times another 5 is 125. Cube root. Cube root is the opposite of cubing. It's or uncubing if you want. It's not a true term, but you can use it. And the question you want to ask yourself is, what number do I multiply by itself 3 times to get the original number? So if I wanted to know what the cube root is, notice there's the index, that little 3 out front, has to be there with cube roots. The cube root is 64. Well, I'm looking for a number I multiply by itself 3 times to get 64. A number times the same number times the same number equals 64. Know what it is? It's 4. Why? Because 4 times 4 times 4 equals 64. Right? 4 multiplied by itself 3 times gives 64. What's a perfect cube? Perfect cube is any number whose cube root is a rational number. So the perfect cubes, the whole number perfect cubes. Well, 0 is 1, because 0 times 0 times 0 is 0. 1 is 1, because 1 times 1 times 1 is 1. Is 2 1? Is 2 1? No. Is the cube root of 2 a perfect cube? No, it's not at all. Is 3? No. 4? No. 5. What's the next one? 8. How do I know that? Because the first one's 0 times 0 times 0. The second one's 1 times 1 times 1. The next one's 2 times 2 times 2. So the next one would be 3 times 3 times 3, which is 27. 4 times 4 times 4, 64. 5 times 5 times 5, 125. 6 times 6 times 6, 216. And I think that's about all you need to know. In fact, you probably only need to know up to 125. Of course, just like the square roots, they go on and on forever. There's an infinite number of square roots. There's an infinite number of cube roots. Okay, it works for fractions as well, or for some fractions, not all of them. If I was looking for the cube root of 8 over 1,000, just treat the numerator and denominator separately. What's the cube root of 8? What multiplies by itself 3 times to get 8? 2. 2 times 2 times 2 is 8. 1,000. What multiplies by itself 3 times to get 1,000? Hint, hint, hint. There's 3 zeros here. How about 10 times 10 times 10? Right? So it's 2 over 10, which is the same as 1/5 in lowest terms. Here's another way you could have done the same question. 8 over 1,000. This is actually a good way to do this. With fractions, it's always good to put them in lowest terms first. You know what 8 over 1,000 is in lowest terms? Well, 8 over 1,000 is the same as 4 over 500, which is the same as 2 over 250, which is the same as 1 over 125. Okay, so the cube root of 8 over 1,000 is the same as 1 over 125. What's the cube root of 1? 1. What's the cube root of 125? 5. We get exactly the same answer. Alright, so we're going to do the same sort of thing. What's the cube root of 1728? So we have to start by doing a factor tree. So 2 times 864, and then 2 times 432, and then 2 times 216, and then 2 times 108, and then 2 times 54. 54, how about 9 times 6? That becomes 3 times 3 here, and 3 times 2 here. Wow. So what we know then is that the cube root of 1728 is the same as the cube root of 2 times 2 times 2 times 2 times 2 times 2. There's 6 of them. And how many threes? 1, 2, just 3 threes. Times 3 times 3 times 3. Now, which club is this? This is club 3. The little index out there is 3, so they all can only come out in groups of 3. Here's a 3, here's a 3, and here's a 3. So, when this one comes out, these 3 2s, you get 2. When this one comes out, these 3 2s, you get another 2. When these 3 3s come out, you get 3. The cube root of 1728 is 2 times 2 times 3, which is 12. That's the answer. What did I want to write in here? I wanted to write something that looks very similar to what we wrote in the other page. The cube root of x cubed is the same as the cube root of x times x times x, which is the same as x. So again, the cube root of 19 cubed is 19. The cube root of 25 cubed is 25, etc., etc. Last question. Is the number 8,000 a perfect square? Is it a perfect cube? Is it neither of those things? Is it both of those things? Well, let's start by making our factor tree. 8,000 is the same as 80 times 100. We could do it that way. 80 is the same as 8 times 10. 8 is the same as 4 times 2. 4 is the same as 2 times 2. 10 here is the same as 2 times 5. 100 is the same as 10 times 10. 10 is the same as 2 times 5. 10 is the same as 2 times 5. So basically what we have is that 8,000, first of all, let's see if it's a perfect square. So 8,000 is the same as the square root of 1, 2, 3, 4, 5, 6 2's, 2 times 2 times 2 times 2 times 2 times 2. And how many 5's? 3 5's. 1, 2, 3. Times 5 times 5 times 5. So this is a square root. It's club 2. We need pairs. Pair, 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 pair. Uh-oh, this thing's left over. Is this a perfect square? No, not a perfect square. Left over. Therefore, 8,000 is not a perfect square. Alright, how about a perfect cube? So you do the same thing, what we just did over here. We'd say the cube root of 8,000 equals the cube root of, same thing, 2 times 2 times 2 times 2 times 2 times 2 times 5 times 5 times 5. This is club 3. We need trios to come out. Yep, there's a group of 3. There's a group of 3. There's a group of 3. Everything's used up. Perfect. So this worked. That means that the cube root of 8,000 is equal to this 2 comes out, we're left with 1 2 there. This 2 comes out, we're left with 1 2 there. This 5 comes out, there's 1 5 there. 2 times 2 is 4 times 5 is 20. The answer is 20. By the way, you could have also done this by using your this one here. You could have done by using the concept with all the zeros. The cube root of 8,000. Well, if you look at 8, that's a cube. That's a perfect cube. What's the cube root of 8? The cube root of 8 is 2. Now there's 3 zeros here. What do I have to do to figure out how many zeros go in the answer? It has to be 1/3 as many. So it should be 20, just like we got. Again, if that doesn't make sense, I'll write it here. The 2 is from the cube root of 8. The 0 is from 1/3 of the 3 zeros in the question. If it's a square root, you need half the zeros. If it's a cube root, you need 1/3 of the zeros. If it was a 4th root, you need 1/4 of the zeros, right? Okay, there you go. Hopefully a lot of that struck you as review, and good luck.